All righty. How's it going, guys? So, Katie, you obviously know. Kale, you might not know yet. Um, but we have a positive COVID case at the high school. So Katie is going to be gone for 2 weeks because she was in contact with that person. And so we're back to the virtual stuff for now. So Katie and I kind of decided that instead of doing Zoom sessions, because her internet kind of sucks, that this would be the best way to hopefully get some information out to you guys. Kale, I saw you submitted the 6-1 assignment today, didn't do super great on it. So what I'm going to do is reassign that to you. I'm going to go through 6-1 kind of quick and dirty, just going to hit the high points again. Katie and I went over it today. Um, so we're just going to go over it again really quick so that hopefully that helps you a little bit, Kale. Again, and then you'll get to redo the assignment again. And then we're going to go through section 2, which is today's lecture, as in Wednesday, 10/28. And you guys will have your assignment for Wednesdays for today's assignment, I guess, too. So anyways, Kale, again, hope you're doing good. You got to get better at email, man. Um, Send me an email. Just, I kind of want to know how you're doing. Um, Also, I haven't had a chance to talk to Kate. I should have done that before now, but when Katie does come back, I'm going to be doing this, I guess, for a little while, so we're probably good for now. But when Katie comes back, if you're ready to start zooming into class and stuff, so that you can get some, you know, a better idea about all the stuff that we're talking about, we can definitely do that. So, anyways, so I'll start with section 6-1. I'm going to do it like I did last time. So I've got my book in front of me, and I'll just kind of hit the high points, and you guys can kind of follow along. Again, Katie, this will just be a good review for you. And Kale, hopefully this will clear up any questions that you might have. So first of all, on page 174, a habitat can be described as an area with a particular combination of physical and biological environmental factors that affect which organisms can live within it. Okay, so first of all, living and non-living factors, physical and biological factors. We know that non-living factors are known as abiotic factors. Living factors are known as biotic factors. And a habitat is essentially everything that has to do with any kind of ecosystem, and the things that make it that ecosystem. So Katie and I talked about some things, some examples of physical, abiotic factors in a habitat would be things like water, amount of rain an area might get. We could also think of something like temperature. Obviously, those two things aren't living, but they are two things that have a big impact on, um, you know, a habitat and what animals are able to live in those habitats. Okay. Within habitats, there are what are known as microhabitats. Um, Again, talked, with Katie about this, and we were talking about how, you guys are both ranch kids. So you, sorry, excuse me. You've been out, moving cows, obviously. So if you think about a reservoir or someplace where, your cattle drink, within that reservoir, there is a micro habitat. The habitat as a whole, the Jordan Valley or Rome or just this high desert area that we live in as a whole is a habitat, but also there are microhabitats. Those, whatever it is, a little reservoir or something like that, even a water tank is a microhabitat for organisms that can't live on land, but can live on water. We talked about how obviously the organisms that live in those areas wouldn't be able to survive if they were on land, which, you know, can be divided by a matter of inches, obviously, you know. We talked about, so say your right foot is in the little reservoir, your left foot's not, right? Your fish that are in the reservoir could obviously survive where your right foot's at, but a foot away, and where your left foot's at, they couldn't survive. So these microhabitats are crucial for different organisms and organisms that play a part in making the whole habitat. So anyways, moving on from that to something that we call tolerance. So each species has its own range of tolerance, the variety of environmental conditions within which it can survive and reproduce. Okay, so we talked about, for instance, polar bears. Polar bears obviously aren't native to this area. They live where it's extremely cold in Antarctica and, you know, the poles. They can survive in these areas. You know, there are polar bears in zoos and stuff like that. But this is not where they are meant to be. And so polar bears that are in zoos, that has an impact on them as a whole. And they have a hard time breeding those polar bears because, like I said, that takes a toll on their body. Likewise, if you were to put a cow where a polar bear is native to, she's going to have a hard time too, right? She's used to Jackie Butte or, you know, Grassy Mountain or Mahogany Mountain, wherever, you know, she's going to have a hard time standing on a glacier finding a blade of grass. So those are all, you know, kind of the range of tolerance, and it varies obviously widely within different species. But they are essentially kind of, you know, what that species can handle. So like a range of tolerance in terms of temperature for humans, for instance, right? Say you were by yourself on an island, didn't have no clothes or nothing. You're just out there by yourself, naked as a jaybird, right? If it dropped much colder than probably, I don't know, 30 or 40 degrees, you'd probably have a hard time staying alive unless you were able to, you know, make a fire or something. Also, if it got over, I don't know, 110, 120 degrees, you'd have a hard time too. So that's kind of, you know, in that example, that's that range of tolerance that we as humans would be able to stand in that circumstance. And that's you know, obviously different between species, but every species has that range of tolerance, basically the extremes with which it can go to and still survive. Excuse me again, sorry. So moving on from that, we talked about a niche. A niche describes where an organism lives and what it does for a living. So that's kind of talking about, you know, what it does for its ecosystem. So for instance, a niche for a fish would be a lot different than a niche for a grizzly bear, right? Fish need water to live. Grizzly bears don't. So those are kind of the different things. You know, a niche, again, just describes where an organism lives and, again, you know, kind of its impact on the environment around it. So moving on from that, should be pretty good. Okay, so competition and the competitive exclusion principle. So earlier we were talking about this, and I used an example with the fish tank here. So every day I feed the fish, right? And I put a little pinch of fish food into the tank. There's the two fish, the betta fish and the, I don't know, stupid, crazy orange fish. And those are the two. The sucker fish is in there too, but he just eats waste, I guess. I don't know. Never eats the food. But the betta fish and the orange fish are the ones that go out the food when I put it in there. So every day I put a pinch of food in the water tank, right? And the orange fish goes crazy, starts eating it like crazy. The betta fish is either dumb or slow or something, has a hard time figuring out for like 10 or 20 seconds that I've fed them. Well, by that time, the orange fish has a lot of the food ate, right? The orange fish understands competition a little better, and it shows in his figure compared to the beta fish, right? He's a lot bigger. Um, and so in terms of competition and the competitive exclusion principle, when I put that fish food in there, there's a set amount of food that is then inserted into that, micro habitat, the fish tank for those fish to eat. Once it's gone, it's gone. And that can be compared to cows in an allotment or something like that. When the grass is gone, the grass is gone. Obviously, a 5-gallon fish tank is different than a 20,000 acre allotment. There's a little bit more gray area in terms of is there feed still or not. But still, the cows that are willing to go out and look for feed are going to probably do better than the ones that kind of hang out by the water tank, don't travel far from the water tank. You guys are both ranch kids. You've been around it. You know that typically the areas around the water tank is what gets feed out first because that's where the majority of the animals are congregating. So the competitive exclusion principle really talks about how animals compete for limited resources, the amount of food that's available to them, and kind of that distribution of the food throughout the different animals in the population. Okay, moving on from that, we'll talk about predation, herbivory. Predation should be pretty simple. Obviously, you know what a predator is, you know what a prey is. In the book, it shows a picture on page 179. You can look of a bobcat and a snowshoe hare. Obviously, the bobcat is the predator. The snowshoe hare is the prey, right? The predator-prey relationship, is basically how those two species interact, how they affect each other's species, right? If something happens and for some reason one year there's like pretty much no snowshoe hares, those bobcats aren't going to have a lot to eat, and there's a good chance the population of bobcats is going to decrease, just like the population of snowshoes. Okay, moving on from that. So we talked a little bit about a keystone species. A keystone, and I'm not talking about a blue can species. I'm talking about a species that has a very, very vital role in whatever ecosystem it is able to reside in, basically. So in the book, on page 180, I encourage you to read that short little section on keystone species. It talks about these otters. And during, let's see, what does it say? And it said a century ago. So 100 years ago, basically hunters killed a lot of the otters. I hunt too. It's okay, but there is a fine line between killing everything and being able to harvest, what the earth has given us, I guess. Anyways, I'm not going to get into that. Besides that, 100 years ago, these hunters killed a lot of these otters in this ecosystem. So the reason why the otters are considered a keystone species is because the otters, their main food source is these sea urchins, okay? And the sea urchins' main food source is this kelp forest. And the kelp forest, which kelp is a giant algae, provides this ecosystem for a bunch of different fish and different organisms in the ocean. When they killed a bunch of these otters, there wasn't near as many of them to eat the urchins. So we saw a huge rise in the population of sea urchins. Now, again, the sea urchins eat the kelp, right? So when there's, tenfold sea urchins now in this ecosystem and they wiped out the kelp forest, now that took away all that place where the other fish and all that stuff was living. So basically, it all goes back to the sea otter, right? And their effect on the ecosystem as a whole. And so keystone species are species that play a vital and unique role in maintaining structure, stability, and diversity in an ecosystem. So without that species, obviously, they're kind of a linchpin species. They have a big effect on the ecosystem. Without them, things change rapidly. I'm trying to think of an example of what would be maybe a keystone species around here. I don't know, maybe jackrabbits, for instance, would have an effect on coyotes. That could be maybe. I don't know. We'll go with it, see where we go. So say for some reason a bunch of jackrabbits get killed. We'll say Kale got a 22 for Christmas and goes wild and kills 800,000 jackrabbits in the Jordan Valley area. I don't know, probably could. I have faith in you. But anyways, we'll say that he did that. Okay, so now there's like 600 jackrabbits left in the whole Jordan Valley area. Okay. So obviously now there's not, we went from 800,000 to 500. There's essentially no jackrabbits left for the coyotes to eat. Okay. So that has a huge impact, obviously, on the coyotes population because that's their main food source. Without that, the coyotes are either going to die or they're going to start finding other food sources, like, for instance, maybe your first calf heifer calves. Okay. Say they come in and start eating your first calf heifer calves. That has an impact on your cow population. Anyways, the point of it is that a keystone species plays a vital role in the ecosystem that it resides in. We'll leave it at that. Okay. Lastly, from section 6.1, and I'm going to stop this video after I get done with 6.1, and then I'll record another one for 6.2 again, so the videos aren't too long and they can post better. Anyways, symbiosis is basically a relationship where two organisms are affecting each other. So there are three kinds: commensalism, mutualism, and parasitism. Commensalism is where one organism doesn't necessarily harm the other one, but it doesn't benefit it either, and one organism is benefited. So the example they give is barnacles on a whale. So barnacles, as you've maybe seen in pictures or something like that, attached to the skin of a whale, right? When they attach the whale, they're not really hurting the whale at all, but it is providing them, because they're eating bacteria and stuff off the skin of the whale, it's helping them. Again, that stuff wouldn't really affect the whale if the barnacle wasn't there, but it does affect the barnacle. That's an example of commensalism. The barnacle is benefited, the whale is indifferent. It doesn't really get affected either way. Mutualism is where both organisms that are, interacting with each other are benefited. The example they give is this sea anemone, which is those giant things with all these fingers and stuff, and then the clownfish. The clownfish don't get harmed by the sea anemone, and they protect the anemone from other predators. Okay, so both organisms are benefited. Basically, neither one of them gets harmed in any way, and they actually both reap benefits from the presence of each other. That is what mutualism is. Okay. Parasitism is where one organism basically benefits at the expense of another one. So we talk about like worming horses, right? Every spring, most of the time, you worm your horses. If you don't, your horses tend to get kind of mangy. They don't do very well. Those worms are harming the horse. Excuse me. At their own expense. I mean, at the horse's expense. Yeah, they're harming the horse and the worms are getting benefited. Okay, so that's what parasitism is. One organism basically benefits by harming another one. Okay, I think that does it for section 1. Again, Kale, I'm going to reassign that one so you can go through it again. Katie, take your time. Make sure you guys do it right. If you have any questions, send me an email, please, so I can help you guys. And I'll see you in just a minute.